welcome to the stage NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC! GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDA-X. Our systems is another platform. And now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. 10 years ago, we decided that we would fuse programmable shading and introduce 2 new ideas. Ray tracing, hardware ray tracing, which is incredibly hard to do, and a new idea at the time. Imagine, about 10 years ago, we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done all together. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it Neuro rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it. Is that incredible? Computer graphics comes to life. Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combined 3D graphics, structured data, with generative AI. Probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these 2 ideas, controlled through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of trustworthy AI. This is structured data. You've heard of it. SQL, Spark, Pandas, Velox, some of these really, really important, very large platforms. Snowflake, Databricks, EMR, Amazon EMR, Azure Fabric, Google Cloud, BigQuery. All of these platforms are processing data frames. These data frames are giant spreadsheets, and they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data. And AI is going to be much, much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches, all of the world's information, about 90% of what's generated every single year is unstructured data. Until now, this data has been completely useless to the world. We read it, we put it into our file system, and that's it. Unfortunately, we can't query it. We can't search for it. It's hard to do that. And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multimodality perception and understanding, to go read a PDF, to understand its meaning. NVIDIA created 2 foundational libraries. Just like we created RTX for 3D graphics, we created cuDF for data frames, structured data. We created cuVS for vector stores, semantic data, unstructured data, AI data. These 2 platforms are going to be 2 of the most important platforms in the future. Super excited to see its adoption throughout the network, this complicated network of the world's data processing systems. And the reason for that is because data processing has been around a long time. And therefore, so many different companies and platforms and services, it has taken us a long time to integrate deeply into this ecosystem.
And now, Vera Rubin. Architected for every phase of agentic AI, advancing every pillar of computing, including CPU, storage, networking, and security. Vera Rubin NVLink 72, 3.6 exaflops of compute, 260 terabytes per second of all-to-all NVLink bandwidth. The engine supercharging the era of agentic AI, the Vera CPU rack, designed for orchestration and agentic workflows. The STX rack, AI-native storage built with BlueField-4. Scale out with Spectrum X co-packaged optics, increasing energy efficiency and resiliency. And an incredible new addition, the Grok 3 LPX rack. Tightly connected to Vera Rubin, Grok's LPU's massive on-chip SRAM, a token accelerator to the already incredibly fast Vera Rubin. Together, 35 times more throughput per megawatt. The new Vera Rubin platform, 7 chips, 5 rack-scale computers, 1 revolutionary AI supercomputer for agentic AI. 40 million times more compute in just 10 years.
We created a brand new CPU that's designed for extremely high single-threaded performance, incredibly high data output, incredibly good at data processing, and extreme energy efficiency. It is the only data center CPU in the world that uses LPDDR5, and incredible single-threaded performance and performance per watt that is unrivaled. And so we built that so that it could go along with the rest of these racks for agentic processing. And so here it is. This is the Grace Blackwell, Vera Rubin, where is it? Here it is, okay? So this is the Vera Rubin system. Notice, since the last time, 100% liquid cooled. All of the cables gone. What used to take 2 days to install now takes 2 hours. Incredible. And so the manufacturing cycle time is going to dramatically reduce. This is also a supercomputer that is cooled by hot water, 45 degrees, which takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center and makes it available for the system. This is the secret sauce. We're the only company in the world that has today built the sixth generation scale-up switching system. This is not Ethernet. This is not InfiniBand. This is NVLink. This is the 6th generation NVLink. This is insanely hard to do well. It is insanely hard to do, period. And I'm just super proud of the team. NVLink, completely liquid cooled. This is the brand new Grok system, and I'll show you a little bit more about it. This system, 8 Grok chips. This is the LP30. The world's never seen it. Anything that the world's ever seen is V1. This is 3rd generation, and we're in volume production now. And I'll show you more about that in just a second. The world's first CPO Spectrum X switch. This is also in full production. Co-packaged optics. Optics comes directly onto this chip, interfaces directly to silicon. Electrons get translated to photons, and it gets directly connected to this chip. We invented the process technology with TSMC. We're the only one in production with it today. It's called COUPE. It's completely revolutionary. NVIDIA is in full production with Spectrum X. So this is the Rubin Ultra compute node. Unlike Rubin that slides in horizontally, Rubin Ultra goes into a whole new rack. It's called Kyber, that enables us to connect 144 GPUs in one NVLink domain. This is the midplane. The Kyber racks, those 4 top NVLink connectors slide in and connect into this, and this becomes one of the nodes. And each one of these racks is a different compute node, and this is the amazing part. This is the midplane, and the back of the midplane, instead of the cabling system, which has its limits in terms of how far we could drive cables, copper cables, we now have this system to connect 144 GPUs. This is the new NVLink. This sits also vertically, and it connects into the midplanes on the back. Compute in the front, NVLink switches in the back, one giant computer. Okay? So that is Rubin Ultra. Let me talk to you about something new. Peter Steinberger's here, and he wrote a piece of software. It's called OpenClaw, and I don't know if he realized how successful it's going to be, but the importance is profound. OpenClaw is the #1, it's the most popular open source project in the history of humanity, and it did so in just a few weeks. It exceeded what Linux did in 30 years. And it's that important. It is that important. It will do, well, this is all you do, okay? We're announcing our support of it. Let me just quickly go through this. I want to show you a couple things. You simply type this. You type this into a console, and it goes out. It finds OpenClaw. It downloads it. It builds you an AI agent. I illustrated effectively what OpenClaw is in this way, and so that all of you can understand it, but let's just think what happened. What is OpenClaw? It connects, it's an agentic system. It calls and connects to large language models. So the first thing it has resources that it manages. It could access tools, it could access file systems, it could access large language models. It's able to do scheduling. It's able to do cron jobs. It's able to decompose a prompt that you gave it into step by step by step. It could spawn off and call upon other sub-agents. It has I/O. You could talk to it in any modality you want. You could wave at it and it understands you. You could talk to any modality you want. It sends you messages. It texts you, sends you email. So it's got I/O. What else does it have? Well, based on that, you could say, in fact, it's an operating system. I've just used the same syntax that I would describe an operating system. OpenClaw has open sourced essentially the operating system of agentic computers. It is no different than how Windows made it possible for us to create personal computers. Now OpenClaw has made it possible for us to create personal agents. This is enterprise IT before OpenClaw, and I mentioned earlier, the way enterprise IT works, and the reason why it's called data centers is because these large rooms, these large buildings held data, held the files of people. the structured data of business. It would pass through software that has tools and systems of records and all kinds of workflow that's codified into it, and that turns into tools that humans would use, digital workers would use. It's just that post-OpenClaw, post-agentic, this is what it's going to look like. This is the extraordinary part. Every single IT company, every SaaS company will become a gas company. No question about it. Every single SaaS company will become a gas company, an agentic as a service company. And what's amazing is this, OpenClaw gave the industry exactly what it needed at exactly the time. There's just one catch. Agentic systems in the corporate network can have access to sensitive information, it can execute code, and it can communicate externally. Just say that out loud, okay? Think about it. Access sensitive information, execute code, communicate externally. You could, of course, access employee information, access supply chain, access finance information, sensitive information, and send it out, communicate externally. Obviously, this can't possibly be allowed. And so what we did was we worked with Peter. We took some of the world's best security and computing experts, and we worked with Peter to make OpenClaw enterprise secure and enterprise private capable. And we call that, this is our NVIDIA OpenClaw reference for NemoClaw, which is a reference for OpenClaw, and it has all these agentic AI toolkits, and the first part of it is technology we call OpenShell that has now been integrated into OpenClaw. Now it's enterprise ready. This stack with a reference design we call NemoClaw, okay? With a reference stack we call NemoClaw, you could download it, play with it, and you could connect to it the policy engine of all of the SaaS companies in the world. And your policy engines are super important, super valuable. So the policy engines could be connected. NemoClaw or OpenClaw with OpenShell would be able to execute that policy engine. It has a network guardrail. It has a privacy router. And as a result, we could protect and keep the claws from executing inside our company and do it safely.
Disney Research uses their Camino physics simulator in Newton and Isaac Lab to train policies across their character robots in every universe.
Ladies and gentlemen, Olaf. Does it?
Snowman coming through. Pardon me.
Newton works.
Wow.
Omniverse works. Olaf, how are you?
I'm so happy now that I'm meeting you.
I know, because I gave you your computer, and you learned how to walk inside Omniverse.
I love walking. This is so much better than riding on a reindeer gazing up at a beautiful sky.
The future of Disneyland, all these robots, all these characters wandering around.
Oh.
I have to admit though, I thought you were going to be taller. Hey, tell you what, you want to help me out?
Hooray!
Okay. Usually I close the keynote by telling you what I told you. We talked about inference inflection, we talked about the AI factory, we talked about the OpenClaw agent revolution that's happening, and of course we talked about physical AI and robotics. But tell you what, why don't we get some friends to help us close it out?
Of course!
All right, play it.
The future's here, won't you come and see? Welcome all to GTC.
great GTC! Wave. Thank you, everybody.
My new
See
best
you,
friends
Olaf.
that I just met